Hello everyone, in today's video we're going to go over why the downhill force is sine theta times mg. And this at first seems unintuitive because when we think of sine of theta we think of a vertical vector, right? Because sine usually stands for the y component of something. But in this case it's actually representing the horizontal component of an object sliding down a ramp of some sort. And a 2D ramp is just a triangle, a right triangle. So when we calculate this, we are given this angle. Hold on, let me make this bigger because just so I can have better mouse, better stroke width. Okay, so this angle is usually what we're given. So let's just say that this is 30 degrees. And usually what they do, what is shown to us is that this angle right here is also 30 degrees. And then it kind of follows, that makes sense. We want to use sine because when we do it like this, we see a triangle forms, and the right angle would be right here. So that means this 30 degrees, the opposite over the hypotenuse would be, let's just say this side is A, this side is C. So the sine of theta would be A over C. And then we know mg is the downward force, and so that would be your C. So if we multiply by mg, and if we know C equals mg, then these just cancel. And so we're left with A, and A is the component, and you can see that symmetry. These are both parallel. And so A would actually be your force vector in this direction as well. It would be your x component. So these are both the same vector. So then you might ask, well, how are these two angles the same then? And the best way for me to explain this is you can see right here in this little corner here, this is also a right angle. And if we know that right angles make 90 degrees, then we must know that this side right here, this angle right here, has to equal 60 degrees, right? Because 60 plus 30 is 90. And so that guarantees, if we know that this side is also, or sorry, this angle right here is also right triangle, and it must, or sorry, right angle, and it must be because this this vector right here is perpendicular to this line. So this angle must be 90 degrees. So that means this is 60, and then that consequently means that this has to be 30 as well. So it's just visually, you have to see where this comes from. And another way to look at this is the way I first figured it out. And I thought about it in terms of transversals, because there's all these lines here. You'd think there'd be something to do with transversals, and there is, but it's a little less obvious. So if we take this angle right here, and this has to be 60 as well, you can kind of see that. But you might not know that that's 60, so you just take that angle there, and then you take this angle here. It's kind of the same idea, but you can see, we can just draw it again if you don't see it exactly, that these are two lines. This is a transversal, right? So this line is the one that's in common with both. Sorry, let me just pick a bigger stroke width. So, oh god, even this happens in this kind of programs. All right, so this line right here is the transversal, I guess. I don't know exactly what the word would be for it, but it's just the line that's common with both angles. And then these are your two, oops, these are your two lines that are parallel to each other. As I keep happening. This is one line, and this is the other. So I just did that up here. And we know from basic geometry that that means that these two angles have to be the same. Forget what the exact phrasing is called. It's not alternate interior, obviously, but or is it? Maybe it is alternate interior angles. But yeah, that's the reason why this angle matches up with this angle. So yeah, that's all I wanted to go over. If you learned something, make sure to hit the like button and comment if you have if you're still confused on it. Maybe I can make a follow-up video or something. But yeah, that's it. Thanks for watching.